So let's continue P-4 on a Friday. Woohoo.
It's like
Okay. Did I leave off at example 5?
No, you didn't.
I did do example 5, right? All right, so here's P-4. Quiet. Quiet. Day 2. Continued. Lines. Perfect timing in the plane. I think is what the title was. Yep, it's close enough, though. All right, so example 6. Find the equation of the line that passes through point P, which is 1, -2, and is parallel to 3x minus 2y equals 1. Keyword, parallel. What do you know about parallel lines? Yep. So parallel lines have the same slope. So your detective, your line passes through this point and is parallel to that line. All I need is a point and a slope. If I find the slope of this line, my line has the same slope. And so then I'll be able to use point and slope. So step 1, find slope of the given line. So we're going to take 3x minus 2y equals 1, and we're going to solve it for y. Because that way I can see the slope. Because here's the joy of slope-intercept form. When it's solved for y, we can see the slope. So that's its big use, along with graphing. So subtract 3x from both sides. We have a -2y is equal to -3x. The 1 is positive, so plus 1. Divide every term by -2. And we get y is equal to the negatives cancel. Take the x out of the fraction, we get 3/2 x, and then minus 1/2. So what is the slope of this line? What's the slope of this line? 3/2. What is the parallel slope? It's a trick question. Parallel slope. 3/2. Aren't they the same, right? We don't want to change the sign. We don't want to take its reciprocal. Parallel slopes are the same slope. So we're going to use that and this ordered pair. So this would be my x sub 1, y sub 1. And so step 2, you're going to use point slope to write your equation. So if you recall, point slope is y minus y sub 1 equals m times x minus x sub 1. We are substituting in for everything but the plane x and y. So write your template and substitute. So y sub 1 is -2. My slope, we just determined, was 3/2. And x sub 1 is 1. So most likely they want your answer in slope-intercept form, so solve for y. So we're going to clean this up a bit. Y plus 2 is equal to, I'm just going to stop here just for right now, only because this would be point slope form, right? But continue, we're going to distribute the 3/2. So when I add, or when I subtract 2 from both sides to get y by itself, I want to subtract 2 as a form of something over 2. The easiest way to convert your fractions is whatever this down here is here that I want it to be. You want to just multiply to that whole number, or that integer. What is 2 times 2? 4. So I'm going to subtract a 4 halves. Negative 4 halves is the same as negative 2. All I did was take the denominator and multiply it to the numerator. Quick conversion. And now I've got y equals 3 halves x, and negative 3 and a negative 4 adding to the sign gives me negative 7 halves. And so there is my equation. And as you can see, both lines have the same slope, but different y-intercepts. Questions on that? All that could change is perhaps you would be given 2 ordered pairs. You won't even be given that. You'll always be given a point and a line that would be parallel, or a line that's perpendicular. So not much is going to change here. We're getting to that. So a perpendicular line. Example 7. Find the equation of the line that passes through point P, which is 2, negative 3, and is perpendicular to the line, or to 4x plus y equals 3. Support your answer on your calculator, which implies that you're going to sketch the graph. So keyword here, perpendicular. What do we know about perpendicular lines and their slopes? So slopes are opposite sign and reciprocals. The slopes of 2 perpendicular lines should multiply to give you negative 1, in other words. They would, in order to give you negative 1, they would have to be opposite signs and reciprocals. So, nearly identical steps. Step 1, you are going to find the slope of the given line. So our line is perpendicular to this one. So we're going to start with 4x plus y equals 3, and the slope is easy enough to find. Subtract 4x from both sides. You get y equals negative 4x plus 3. What is the slope of this line? The actual slope of this line? It's negative 4. What would be the perpendicular slope? So change its sign, positive, and what's the reciprocal for? 1/4. So our perpendicular slope is 1/4. So this is the slope we want to use with that point. So on that point, 2 is x of 1 and 3 is y of 1. So step 2, we are going to use point slope. So we've got y minus y sub 1 equals m times x minus x sub 1. Write in your template. And then substitute in your values. So for y sub 1, I have negative 3. For my slope, we're using the perpendicular slope, which is 1/4, because that's the slope of the line we're trying to find. and the x value is 2. So to clean this up, again, my guess would be that they want the answer in slope-intercept form if nothing said. But this would be point-slope form if they ask for it. We're going to distribute the 1/4. So 1/4 x. 1/4 times -2 gives me -2/4. Isn't that -1/2? 2/4 reduces to 1/2. And so when I subtract 3, again, the quick method, take the 3 and multiply it to the denominator. 3 times 2 is 6 over that same denominator of 2. Isn't -6/2 the same as -3? So now I can complete that. So I have y equals 1/4 x. Same sign, so add and keep the sign. So 6 and 1, I get a -7/2. So here is my line. And so then we want to whip out our handy dandy calculator, which I have to go run and get one. And you put both equations into y equals. So the first equation is this one, so I'm going to put in -4x plus 3. And the second equation is this one, using parentheses, 1 divided by 4x minus 7 divided by 2. You should find that the lines appear to be perpendicular to each other, so they should be at right angles to each other. Now it looks like they're almost not. Why do you think that is? It looks like they're not, it's not quite a right angle there. Why do you think that is? Look at your viewing screen. Does this scale look like it's slightly different than this scale? Don't these look further apart than these ones? So if we went into zoom, square, now the scales are identical, and now look at your line. Doesn't that look perpendicular? So in the standard viewing window, the scales actually aren't distanced the same apart. You still have 10, 10, 10, and 10 on all four, but this is typically wider than this distance. And because this is not a square here, this is a rectangle. Let me see. Probably one of them is not lit up. Let me see. So Brandon's is only showing one line. So this one. So if we go into his y equals, notice, oh, you have this thing on the side. So we're going to reset your calculator. So if you see what looks like a video thing over here, we're going to, and plus, notice how that one's not lit up. You really shouldn't have this over here. It's going to create issues in the future, but for right now, I'm going to go over here. I'm going to go to the left, and I'm going to hit enter. Oh, because it's only letting one at a time do it. So we're going to go through and do second. Whoops, second click. Quit. We're going to do second function. We're going to hit the plus. You're going to hit 7. And you're going to hit 1 and 2. Now, if I go back into y equals, see how it's normal again? So now plug in your lines, and you should get both lines. So if anybody else, when you look at your y equals, if it doesn't have these diagonal lines here, go through that reset. Second, plus, 7, 1, 2. You would store data in there, but what do you need to store data for? That would refer to a game. Plug-ins, yeah, I know. All right, so we're good with that. Okay, bear in mind that your calculator is not in the standard viewing window anymore. All right, so then let's look at some word problems. So example 8. Yeah. What? Oh, yeah, we forgot to sketch it, didn't we? Oops, thanks. Oh. Sketch. You can sketch it right, though. We have to sketch it. If they do say, you know, support on your calculator, it's a sketch. And Math Excel is going to, you know, make you graph it. But you just have to graph your, really all you have to do is graph your line intercepts, and then stair step a slope to one more point, graph that point, and connect the lines. We won't take the time to do it. I think you all can do that. Camelot apartments. Purchased a $50,000 building. No, not a two. For tax purposes, its value depreciates $2,000 per year over a 25-year period. We all have that written down. Still writing. What's $2,000 times 25 years? 50,000. So that's why it says over a 25-year period. After that, it becomes a negative value. So we're going to write the equation of a line that's depicting this. But in real life examples, we sometimes will ignore the parts of the line that are not realistic. So in other words, if it's a negative time, or in this case, a negative value, that's the part where you're like, okay, depreciation's over with. The asset's no longer worth anything, if much. So, although they could probably sell the building for something after that, for tax purposes, it can no longer be depreciated. It'll no longer be considered an asset. All right, so write a linear equation giving the value y of the building. So in other words, they're saying that y is going to represent the value of the building in terms of the years x. So they're saying the years have to be x. I'd be writing this. It's not a observation. We're all writing after purchase. So linear equations are in the form of y equals mx plus b. Because of the variable, the mx is your variable term. Your b is your constant. So in these problems, you're looking for what is the constant and what is the thing that changes, in this case over time, because x is time, it's years. Things that remain constant would be original purchase costs. Think of it used to be with your cell phone, it's changed a lot since cell phones first came out, but it used to be with your cell phone bill that you would be charged a base amount, and then you would be charged on top of that a price per minute used. If you get into a taxi cab, isn't there like a charge just to get on? I know we don't use a lot of taxis here in the Phoenix metropolitan area, that if you were to get in a taxi, just sitting in the taxi, they're going to charge you like $5 just to sit in the taxi and go nowhere. That's a constant charge. Then they're going to charge you so many dollars per mile. What else do you think of where there's a base charge and then they charge you a variable charge? Yes, I see what you're thinking. He's thinking in terms of I purchased something and I put something down. They're not going to use that for this purpose because what you put down wasn't an original total purchase cost. But what you could use is your total purchase cost, and then your variable amount is what you pay on it every time. So that could be that. What about if somebody comes to repair something at your house? A plumber, air conditioning man, appliance guy. Typically, they're going to charge you a service charge. They may come to your house. This has happened to me. Come to your house to fix your air conditioning, and it was because something wasn't turned on or connected properly. I had one air conditioning guy disconnect the heater part so that they would be able to come back in the winter months for another charge. Because obviously it didn't get disconnected by itself. So my point being, the guy was there for like maybe 5 minutes. Do you think he charged me money? Of course. He charged like an $85 service charge to connect a little while. Yeah. Oh yeah. And my daughter's getting married, so I'm looking to rent linens for the reception. So I put out a bid to her place, and I happened to bid on just linens for a bridal shower. So we were only buying, I don't know, renting like 3 tablecloths. It happened to be a company out in Gilbert. So the tablecloth, it was going to cost me like $30. But the charge to deliver the tablecloths was $150. So I didn't go with them, obviously. I was just curious to see what they would say. But they're that $150 delivery charge, that's a constant. The variable would be how many tablecloths am I renting. So there's always a variable amount and a constant amount to most anything that you buy. So in this case, what is our constant amount? So the $50,000 is going to represent our B. So that $50,000 is going to be our B. Then what's going to be our M? Yeah, every year this $50,000 is going to go here is reduced by $2,000 each year, and then after 25 years it becomes 0 and it'll become negative. And we'll see on the graph in a minute why that is. So this is actually our M. But with your M, you have to decide, is it a positive or a negative? Since it decreases our constant, this is going to have to be a negative M, won't it? So we're ready to write that equation. So we get y equals negative 2,000 M and then plus 50,000. Oh, sorry, thanks. I don't know why I put M. Good question. Should be X. And so this is our equation that they're looking for. Then we're going to do some stuff with it. So that would be part 1 of the question. So then part B. In how many years will the value of the building be $24,500? So what is it that I don't know? How many years? So how many years is my unknown? Is that my X or is that my Y? It's my X, right? Because they noted X way up here. Where'd it go? Oh, right here. So X is your number of years, right? So we're just going to plug into that formula. So I have y equals, or what goes in for y? Yeah, so that's our value. Y is your total value. Total value at each particular year. At each year. So we're going to put the 24,500 in for y equals negative 2,000 x plus 50,000. So we're solving for x. So subtract 50,000. What do I get? What do I get? 20 what? 25,500 would be correct, but it's a negative, right? Equals negative 2,000 x, then divide by negative 2,000. And it's not going to go in there evenly. So take your handy dandy calculator. So the negative should cancel out to give you a positive in 12.75 years, right? So x is going to equal 12.75 years. Now you're going to have to find out what Math Excel will accept. So therefore, the building will have a value of $24,500 after 12.75 years. They may want you to round up to the nearest year or round down. Because technically, for tax purposes, if the year hasn't completed, it hasn't occurred yet, but we won't go there. So questions on that? That's easy, right? All right, last problem and last word problem. This one's going to require a little bit of room. You have to draw a scatter plot. So hopefully you have graph paper. Hint, hint, wink, wink. Example 9. Americans, plural, and the apostrophe is after the S because it is possessive on a plural. So Americans, total personal income, in trillions of dollars. Wish I had $1 trillion of income. In trillions of dollars is given below. So you need a scale. We're going to go 8 vertically, give or take, and 8 to 10 horizontally, give or take. I'm going to have a bit of a broken line graph. Don't let that bother you. This is going to be 8, 10, 12, 14, 16, we'll stop at 18. And then this is going to be year 2002. So I'm going to put 02, 04, 06. We'll stop it already. Try to plot your points pretty much where I'm plotting mine. So you have one ordered pair that's at 02 and slightly above 10. So 02 slightly above 10 but not halfway. 02 slightly above 10 but not halfway. And then for O3, you're going to have slightly above 12, but not halfway. And for O4, you're going to be at 14. For O5, you're going to be slightly below 16. For O6, you're going to be at, well, just slightly below 14. And at O7, you're going to be directly in the middle between 14 and 16, so you'll be at 15. Then take a straight edge, and I want you to connect, sort of, these three lower points here, but this point, what is that? This point here is just barely touching it. So do your best to create that. If it's not exact, don't worry. It'll only matter at the end. Tyler, did you create that? I don't see anything on the paper. Is it in pencil? Use color, my dear. Color brightens up your entire world. It creates unicorns and rainbows. It makes you so happy. Okay, so part A. Write a linear equation for Americans, possessive plural, income, Y, in terms of the year X, using, and this is time, the points my X bled in on the other side, sorry. Using the points 2005, comma 10.5, we're close enough on ours, and the point 2010, which is not on your graph, comma 12.4. Is that in here? 12.4. So we're writing a linear equation given 2 points. Now, the points in years are quite large. If I were you, I would just be using 05 and 10 for those values. Right? Be a lot easier. So, how do we write an equation given 2 points? That's my favorite thing. Y minus y sub 1 equals m times x minus x sub 1. But before I can use that, what do I need to have? Slope. So first things first. So step 1, slope. So m equals, use your template. Take your y's. I tend to like to take the bigger and subtract the smaller, so I'm going to take 12.4 and subtract 10.5. Since I started with 12.4, my x had better be 2010. In this case, I'm just using 10 in the denominator, and I'm going to subtract 05. So we will get a decimal. This is a word problem, and I know that I told you yesterday we don't use decimals as slope, but this is a word problem. It's going to be okay. So we're going to have 12.4 minus 10.5, which gives me 1.9. What am I going to divide it by? 5. So I get a slope that is 0.38. And it makes sense that's positive because isn't this a positive slope for Americans' income? Obviously, we didn't take into account current incomes, but we like to look at happy times. All right, so choose a point. Does it matter what point you choose? No. I'm going to choose a smaller point. It really doesn't matter, but I'm going to choose this point to go along with our slope. So we're going to plug those in. Y minus, and for y sub 1, we're going to put in 10.5 equals, our slope is 0.38 times x minus, and we're going to use 0.5. Distribute your 0.38, so we have y minus 10.5 equals 0.38x minus, and then we're going to multiply that by 5, so I get 1.9, and then we're going to add 10.5 to both sides, so 0.38x so I multiplied that by -1, so it would become negative, and then I'm going to add 10.5. So we get 8.6. So a positive 8.6. And that looks about where this line is crossing, give or take, right? The y-axis, that would be the y-intercept, and this is the slope of that line. Because we used, well, we didn't exactly use those points, but we used the points they gave us, which hopefully should be close enough on that line. So that's part A. If you get part A wrong, you're going to get the rest of the question wrong. So when you're doing your homework, if you get that part wrong, you can't go and finish it. So then part B, use the equation in A to predict Americans' possessive plural, I squeeze it in there, income in 2015. Now I do have an issue of using, well, I have an issue of using 2005 and 2010 income to predict 2015, don't you? Did something happen between 2010 and 2015 that might have affected income? We've had a depression, haven't we? So I don't feel that this answer is going to be realistic because we don't have an increasing trend in income. There actually was a big dip, and then you'll start to see them increasing again. But don't let that bother you either. All right, so where are we going to put that 2015 in? For x or for y? X is the time, right? Are we going to put 2015 in there, or what are we going to put in? We're just going to put in 15, right? Because that's what we used originally. So we're putting 15 in here, just that part, and we're going to run it through the calculator. So 0.38 times 15 plus 8.6. 14.3, and what is that in terms of? Trillions of dollars, right? And then last question, we are going to superimpose superimpose a graph of the linear equation in A on the scatter plot above. So they actually kind of start at the same place, don't they? You can do that on your calculator. We can go into, it might take us a little bit longer, but we can go into lists, go into stat, hit your stat button, and click on edit. If your lists are not blank, go up here and hit clear, not delete, hit clear. And it should clear them. Did it? Does anybody have information or lists that you want me to demonstrate up here? Let's say that I put this in here and I wanted to clear it. Go up here and hit clear and enter. And it should clear. If you hit delete, you totally delete the list and then you have an issue. Alright, so what I want you to put in there is, I want you to put in O2. I'll just put in 2. 2, 3, 4, 5, 6, and 7. So put in 2, 3, 4, 5, 6, 7. Then go up to list 2. And for 2, we're going to put in, they gave us 10 points. Oh, that was for 5. Alright, so for O2, let's put in 10 point, we're going to estimate 10 point, what do you think? 2. Hit enter. And then for O3, let's put in 12.3. I'm just estimating. And for O4, we're going to put in 14. And for O5, we're going to put in 15.8. And then for O6, we're going to put in 13.9. And then for O7, we're going to put in 15. Those are in your lists. Then hit second quick. Go to, see where it says stats plot up here? Go to second y equals. And you want to enter on 1, just hit enter. And we want to turn that stats plots on, so hit on. So that's blinking, so we'll hit enter. And then you want a scatter plot, so this right here represents a scatter plot. If it's not lit up, then take your cursor and go over until it's lit up and hit enter. But you want that first one lit up. That should be your scatter plot. And then your X list is L sub 1, your Y list is L sub 2, and your marks are going to be these little dots. Does everybody have that on their stats plot? So then go into Y equals, and you want to clear out these equations from before. And you want to put in the one that we came up with here. This one here. So put in 0.38x plus 8.6. And notice that your plot 1 is highlighted. It should be. And then just hit graph. There's an issue. We need to change our viewing window, right? So we want our viewing window to read what we have here. So let's go from 0 to, well, we want to go here. So go from 0 to 10. So x min is 0. X max is, oh, let's do 20, just for chuckles. And then we'll go by 2s. So this is my x scale, 0 to 20. My y min is going to be 0. My y max is going to be 20. And we'll also go by 2s. 0, 22. Now hit your graph. There it is, superimposed. So if we were to put it on here, our graph actually would go like this, wouldn't it? Give or take. It went a little bit below it, didn't it? But notice that we also use different points that were on this graph. We used points that were way far out in the future than what was on here. We used 2010 and 2005 was the only one that was the same one that was on there. So we probably should have had 05 here be 10.5, but that's not what they showed on the original graph in the problem. So there you go. That's it. Questions on that? All right, so come Monday with questions on P3 and P4. Make sure that you completed your homework through to P4 by the weekend.